Welcome back to chapter 6. We are still on section 6.2. This is the last video for section 6.2 and it is about applications of trigonometry of right triangles. So here we will see some real life problems in which we can use trigonometry and solve them. The method of doing these problems is to first thing to do is to draw a diagram. I won't say picture, a diagram. A diagram is kind of a sketch of the situation or of the picture. So we will basically use lines to represent heights, distances, or lengths, and so straight lines. Okay, and so the most probably, since we have dealt with right triangles, so here we will get right triangle or triangles which to which we apply our trigonometric ratios, and we should be able to find out the solution of the problem that has been asked. So looking at the first example, it says a 600 foot guy wire is attached to the top of a communications tower. If the wire makes an angle of 65 degrees with the ground, how tall is the communications tower? So now it's very important to make the diagram. If you don't do that, you will lose some points. Okay, so we can show it like this. We can draw the diagram like this. You can make it on the right or on the left, it doesn't matter. So this is the ground. Sometimes we can do that to show that this is the ground. Now tower could be any height. Now I can have the tower here or I can have it over here. Doesn't make much difference. This will be the same thing. So let this be the tower, and from the top of the tower to the ground we have a guy wire going. Why do we put guy wires? Those are for making the tower stable. Okay, so this angle the guy wire is making with the ground is 65 degrees, and the guy wire itself is 600 feet long. So we have to find the height of the tower. So if you want, you can call it H or X or A or whatever you want. Okay, so this is, or T even. We have to find this, so we have to give it a name. Now the ground, if you notice, this is now a right triangle in which we know the hypotenuse, which is 600, and we know this angle at 65 degrees, and then we have to find the opposite of the 65 degree angle, so the length of the opposite side. That's what we need to find. So that's how you connect this problem, real life problem, to trigonometry. So in trigonometry we are saying that the length of the guy wire is 600 feet. It is making an angle of 65 degrees with the ground, and we have to find the height of the tower. So how we convert it into mathematics? We say, okay, we have a hypotenuse of 600 feet, of length 600, and we have our angle is 65. So, and the opposite side is what we want. So this is the hypotenuse and this is the opposite side. So what relation combines the angle and its opposite and its hypotenuse? If you recall, that is sine of the angle. So we can write here now sine of 45 degrees is equal to O over H. So little h divided by 600, and that's it basically. So from here we multiply both sides by 600, so we end up getting h is equal to 600 into sine of 65. Sorry, no, not 45, 65. So I made a mistake here. this is supposed to be 6. Now we don't know the sign of 65 because that was not in our on the unit circle in our known known angles or known numbers. So we will leave it like that. If you are in the exam, you will say the height of the tower is so many feet. Okay, so that's how you will finish your answer. But in the at home, when you are doing it for homework or online homework, you can take the calculator and plug in these values and get your answer. The important thing you have to remember is that when you are plugging in, your calculator must be in degree mode. So 543.78 feet, that's what we are getting. So now you can say the height of the tower is, so instead of this value you can say 543.78 feet. Okay, now this was very simple, but we can have complicated ones as well. So let's look at the next one. This is quite complicated. Okay, so it says a woman is standing. A woman standing on a hill sees a flagpole that she knows is 60 feet long. Okay, now so the angle of depression to the bottom of the pole is 14 degrees and the angle of elevation to the top of the pole is 18 degrees. Find the distance x from the pole. Find her distance x from the pole. She is at a distance of x feet because we are using foot here. So what is that distance? That's what we have to find out. But let me first explain what is angle of elevation and what is angle of depression. So assume like a person standing here. Can I make that stick figure? Okay, so person is standing here and they are looking down at something. So if you are looking down at something, the angle that is made with your line of sight, this we call line of sight or line of vision, sight. Okay, and with the horizontal. So this is the horizontal. This angle is called angle of depression. And then if you are looking if someone is looking above, if someone is looking up at something, then this is the horizontal and this is the line of sight. So this is the horizontal. So this angle is called angle of elevation. Okay. So let's see what our picture looks like. So we have a hill. So let me make the hill here. So let's say this is the hill and the woman is standing here. And then there is at a certain distance from the hill there is a pole. So this is the ground. So when the woman looks down, now we are not considering the height of the woman here, okay? So we are just looking at the from, you can say, from the level of her eye. Even if I from the level of her eye, so she's looking down here, so the angle of depression is this one. So this is 14 degrees, and then when she looks up to the top of the flagpole, so let's say there is a flag attached to it. So when she looks, again you don't need to make the flag, but when she looks at the top of the pole, this angle is 18 degrees. These are given. So we want to find the distance between the, so you should be able to see that the distance between the woman and the pole is this length. This is x. This is what we need to find. So how do we work with that? Oh, by the way, another information that is known is that the height of the pole is 60. So this total height is 60 feet. This is something we know. So how do we proceed from here? We will start by looking at the two triangles. Can you see two right triangles here? Yeah, so that's what we will start with. But the only kind of information we have is, for example, from the top triangle we have 18 degrees and then the x, which is we have to find. We don't have any other side known. But this 60 degree, this is something that should help us, see what is help us see which trig ratio we will use. So what we can do is, because we don't know the height of the hill, so we don't know what is this much and what is that much. Okay. So what you can say is, you can give them name, let's say A and B. So then we have the two triangles. Well, again, hope you can see those two triangles. The one is like that, and this is 18 degrees, this is x, and this is A. And the other triangle is this is 14 degrees, this is x, and this side is B. So we know that A plus B is 60, right? Over here I can even write A plus B is maybe A plus B is equal to 60. So using this information, we want to see if we can find A and we can find B. Now we might not be able to find exactly what the value of A is in the beginning, but that's fine. Okay, so but we can write from this triangle, that this first triangle, we can write that A over x is equal to tangent of 18 degrees. So that A is equal to x times tangent of 18 degrees. Okay. Now looking at triangle B, this second triangle, we have B over x is equal to tangent of 14 degrees. So that B is equal to x times tangent of 14. So now that we know that A plus B is equal to 60, A plus B is equal to 60, so we can say x times tangent 18, which is A, plus x times tangent 14, which is B, is equal to 60 degrees. So it's not that bad. So now we can factor out the x, and inside we have tangent of 18 plus tangent of 14 is equal to 60. So that x will be equal to 60 divided by tangent of 18 plus tangent of 14. So this will be our answer. Okay. So we will say the distance between the woman and the pole is this much. Okay, I need to shift these up so that I can fit my is 60 divided by tangent of 18 degrees plus tangent of 14 degrees. So many feet. Do not forget the unit, okay, when especially when you are writing in words. Okay, so now we have it. We have got the answer for the. So now the thing is, one can be confused, like how do I know I have to do the problem in this way? So you can do it in some other way. I mean, like there is not just one way of doing it. We can think of some other ways to do it. For example, we have this situation. We know that the woman, this is the top of the hill, this is the flag. We saw that we had this scenario going on, right? Okay, so we know this is 60 and this is x, and these are the angles that, if this is 14, this is 18. Okay, so we could also do it like this. Okay, this is x we have to find, but we don't know what it is. So here we can call one of the side as y or a or b. So if one portion is y, it doesn't matter which one, just take one of them to be y, then the other one will be 60 minus y. So now you can write from the top triangle. Again, you don't even have to split them like this. I did that just to show you which triangles I am talking about. So this is 18 and this is x and this is y, and the other one will be that this is 14, look, and this is x, this is 60 minus y. So you can say tangent of 18 is equal to y over x, and then the second one will be tangent of 14 is equal to 60 minus y over x. So now what to do? So what we can do here is find y from here. So from here y will be equal to x times tangent of 18, and from here I have to find y, but I cannot find it in one go. I have to do it in steps. So the first thing to do is multiply both sides by x. So we get x times tangent of 14 is equal to 60 minus y. Now we can add y to both sides. So you get y plus x tangent 14 is equal to 60. So that y will be equal to 60 minus x tangent of 14. So now we have two equations for y. so two results for y. So we have y here, and then we have y. So in one problem, if for one variable you have two different values, it means those two values are equal to each other. So this gives us, these two give us that, because y is equal to y, so we can say x tangent y tangent 18 is equal to 60 minus x tangent of 14. So now you see it's kind of coming to the same result as we got before. So we will combine the x terms, so move this over here. So we get x tangent 18 plus x tangent 14 is equal to 60. Factor out the x, tangent 18 plus tangent 14 is equal to 60. So that x will be equal to 60 divided by tangent of 18 plus tangent of 14. So got the same answer. So that's how we do these problems. Okay, so we are going to look at the next problem, but need to erase some stuff here. Okay, so what is this one? This is saying to measure the height of the cloud cover at an airport, a worker shines a spotlight upwards at an angle of 75 degrees from the horizontal. An observer 600 meters away measures the angle of elevation to the spot of the light to be 45 degrees. Find the height h of the cloud cover. So what is the situation? So we have a cloud somewhere here, and there is a, doesn't again matter which side you put the worker and which side you put the observer. So let's say this is C. So this point is C, and this point is the point where the worker is shining the light. So the line from the light to the cloud, if you are going to consider the height of the person, or height wherever the torch is. So this is the, so this angle now with the horizontal, this angle is 65. Well, I think it should, yeah, I think it's okay. So now the observer is maybe somewhere here. So when he is looking at the shining spot, so this is the worker and this is the observer. So his angle of elevation is 45 degrees. So we have to find the height. So we need this height. Okay. So let's call it h. Then again you see, okay, this was 75, right? So we are now going to look at the two right triangles. So what are those right triangles? One is this angle is 75. This is h, and on the other side this is 45 and this is h. Also we know the distance between the observer and the worker. So the distance between the observer and the worker is 600 meters. They are 600 meters away. So this distance is 600 meters. So now it's kind of similar to what we did over there. So we can call this distance, we can call it A, and the other one, this one, we can call it B. So what is A? How will we find A? We can use the tangent. Tangent of 75 degrees is equal to h over A, so that A will be equal to h divided by tangent of 75 degrees. And then what is B? So we say tangent of 45 degrees is equal to h over B. Now we know the tangent of 45 is 1. So tangent of 45 is 1 is equal to h over B, so that B is equal to h. So the B and h are of the same length. Now we know that A plus B equals 600. So we can say h over tangent of 75 degrees plus h is equal to 600. So that how can you find? We have to find h, remember. So we have to get h to one side, so h times, and side we are left with 1 over tangent of 75 degrees plus 1 equals 600. So we can just now divide by this quantity and we get our h. But if to simplify it a little bit, h will be equal to 600 divided by 1 over tangent of 75 degrees plus 1. So you can leave the answer like this, or I would say I never leave the answer in a mixed or complex fraction. Always try to get it in a simple fraction. Means there shouldn't be like 3 steps in the fraction like we have here. So it will be 600 divided by, so take the common denominator here. So we get 1 plus tangent of 75 over tangent of 75, which becomes, the bigger line is here, so the division sign will come right after 600, so which means this will be flipped. So we get 600 into tangent 75 over 1 plus tangent 75. So the height of the cloud is so many meters. Again, now if the question asks you, you can even convert it into decimals. And did I do that? Okay, this is approximately 473 meters. Okay. Okay, so this is how we do these problems. Okay, so thinking about how making the diagram, and then thinking about which trig ratio will help us solve the problem. And there could be any of the trig. In these examples, in two of these examples, we use the tangent, and in the first one we use sine. So this is how we do these application problems with right triangles.